Leaders Live, where I get the chance to chat with luminaries in e-discovery and related areas. Welcome to eDiscovery Leaders Live, hosted by ACEDS and sponsored by Reveal. I am George Socha, Senior Vice President of Brand Awareness at Reveal. Each Friday morning at 11 a.m. Eastern, I host an episode of eDiscovery Leaders Live where I get the chance to chat with luminaries in eDiscovery and related areas. Past episodes are available on the Reveal website. Go to revealdata.com, select resources, then select eDiscovery Leaders Live. We have two guests here with us this week, both my colleagues at Reveal, Dr. Irina Matveeva and Dr. Dave Lewis. Dr. Matveeva is Chief Data Scientist and Head of Machine Learning here at Reveal, and Dr. Lewis, Executive Vice President, AI Research, Development, and Ethics at Reveal. Let me give you a little about their background, and then we will launch into our discussion. So Irina, as I mentioned, is Chief Data Scientist and Head of Machine Learning here. She is responsible for Reveal's data science organization and applying machine learning and natural language processing throughout the Reveal platform. She also is an adjunct professor at Illinois Institute of Technology, has nearly a decade of both practical and academic experience in natural language processing, has co-chaired the text graphs workshops in 2007, 2008, 2011, and 2012, and is a reviewer for multiple prestigious journals and publications. Dr. Matveeva has her PhD from the University of Chicago. Dave Lewis, Executive Director, AI Research, Development, and Ethics at Reveal, is responsible for artificial intelligence research, development, and ethics, no surprise there, or ethics issues rather, throughout Reveal's software and approach to e-discovery. Prior to joining Reveal, he held positions at BrainSpace, recently merged with Reveal, AT&T Labs, Bell Labs, and the University of Chicago, along with co-founding a machine learning startup and consulting on numerous cases. He's been elected a fellow of the American Association for the Advancement of Science. That was in 2006. And in 2017, he and W.A. Gale won the ACM, you'll have to tell me what this is about, Dave, the ACM SIGIR, or SIGIR, Test of Time Award for the invention of uncertainty sampling. Dave has his PhD from the University of Massachusetts at Amherst. Irina, Dave, welcome.
Thanks, George. Good to be here.
Hello, George. Thank you. Thank you for having us.
Glad to have you both. We have in the outline of topics we could cover for this 25 or so minutes coming up. I think we've got about 12 hours of content. Obviously, we are not going to get to all of that. But I would like to start with some of the things that are highlights of what Reveal is doing now and where it's going now, which is all about artificial intelligence. As we think about the use of artificial intelligence, especially with respect to electronic discovery, Irina, what are some of the problems that we are able to solve with AI?
So I think we can solve really a variety of problems. And the way we are approaching it here at Reveal is that we're thinking about solutions, right? It's not even so much what individual problems we can tackle with AI. It's more what are complex solutions or what are the complex problems which we can solve with our AI solutions. And we're trying to hide the complexity from our users. Right? From the user perspective, it should be as simple as a click of a button and they get some results. And so we've been working on the privileged communication detection solution. and sexual harassment detection solution, and a number of others. And of course, we've partnered with the DLA Piper Ascensions organization to discover cartels and potential cartel behavior. So that's another example of the problems which we can solve using our AI solutions.
So, Dave, is it about particular machine learning technologies? Is that what we should be focusing on as we look at these solutions, or is there a different area of focus?
Well, I mean, for people like Irina and I, absolutely, that's what our job is. But I think for the users of the system, it's much more about process and workflow. I don't think that attorneys and investigators need to be reading the latest deep learning literature, things like that. But what we try to do is make it easy for people to manage these technologies in the context of a workflow where their human experts are able to get their knowledge into the system, have it amplified by the software, and then get the jobs done that they need to get done. And I think the educational thing that's important for people in AI is to help the users understand what the software can do, what it can't do, how you can maximally save costs, what some of the failure modes are, things like that. But I think sometimes people in e-discovery have gotten a little too focused on support vector machines versus logistic regression versus deep learning or things like that, where it's probably a level or two up that's more important.
Well, let's try taking it then a level or two up. And so we're not going to talk about support vector machines, any of that, at least not right now. I'm going to switch back to you, Irina, to talk about a concrete example of the use of these technologies with what DLA Piper has done with Ascension.
That's right. That is, I believe, a perfect example. Obviously, I'm part of the project. I'm extremely excited about that. But I believe it really showcases of what AI can offer. We partnered with the Ascension team, and what they brought to the table was the expertise of their lawyers, the kind of decades worth of expertise working on cartel cases. They worked with our data science team. They educated us about the cues and the signals and features, what they are trying to find in the data when they approach a new case. Because every case is different, and yet there are some commonalities in the cartel behavior. So they worked with us and really conveyed that knowledge to us of what they are looking for, what is their playbook, so to speak. And we worked on encoding the steps of that playbook in the models and filters, NLP technologies that we're using within our system. So then, in the end, we have this model, which will go to their own model library, and they can use and reuse in the future cases. And our data science team did a very thorough evaluation on multiple existing cases or historic data which we had available. And we did show that those models do find cartel behavior, in new cases that the model has not seen before.
For both of you, and this is something you alluded to a moment ago, Irina, there are and there will be any number of lawyers who will say something akin to what you'd said a little earlier, and which I've been hearing since I started practicing in the 1980s. Every case is special. Every case is unique. You cannot take a machine or anything like that and point it at a case and just have it do things, because the lawyers have to look at the case and figure out how to handle this unique, special, unlike anything else thing. And we know that's not really true, but how do you deal with that in something like this? Irina, did you run into something like that with DLA?
Sure. Even with the DLA project, some team members were fairly skeptical, and they were very open about that. But I think we are also learning to work with our clients and understand how the clients see the problems and how they see the use of technology. So what I've been learning is that, so the first thing is that we're using AI as augmented intelligence. of course, the lawyer will be in the loop. Of course, we were learning from the expertise of the Ascension team, and we will be learning in the future. We still are working and partnering with them. And of course, the human will be making the final decision. And yes, the lawyers will be reviewing documents, understanding the players, and so on and so forth. So there will be this involvement. So the model cannot solve it completely. At the same time, it can really augment the process. It'll give you great candidates. It'll point you right to the pocket of data where the problem may be. So then it's much faster, more efficient, and you use your time in the best possible way. And the second explanation, more from the machine learning perspective. So now, Dave, I'm going just a little bit, under the hood, is that machine learning technology does work, and it works in really very powerful ways. So we see it in our daily lives, right? And here we did a very thorough evaluation. We were also it's scientifically skeptical about the approach. We said we do not believe it until we see it works. And we convinced ourselves, and then also we see that our clients see that from the practical perspective also can convince themselves that this approach is scientifically solid as well. And the model learns from hundreds of thousands of parameters, depends on the model, of course, but it's a very powerful technology, and it can really pick up on the most important features or signals in the data, right? So it actually can pick up on the common things which exist across multiple cases, although even each case might be different and unique in its own right, there will be some commonalities, right? What is the cartel behavior? There's a definition, and you have to exhibit some of the components of that behavior for that document to be responsive, let's say, if you're looking for cartels, right? So those commonalities are common, right, as the word says, across the cases, and the model can pick up on those features and signals.
So, Dave, you have had to have run across the same concerns and objections, right?
Yeah. I mean, I think this comes up particularly in the context of the brain space portable models capability, and this is much like the things that Irina is talking about, where people are producing models that they intend to apply to multiple cases. And I think one of the big ways that we've addressed that concern is through an emphasis on interpretability of the models. We have the model insights capability that lets you visualize what the most important features are, and then show how you can take, say, let's say, for instance, you've got a model that's trained for fraud detection, and you've used it on 3 cases, and you bring it into a 4th case. As you then tune it, and we always encourage people to tune models to each new data set, you can sort of watch through model insights how the important terms are changing. And you might have a term, a certain phrase that was very predictive on case number 2, but on case number 4, it's actually not predictive or even anti-predictive. And so you can sort of see things like that because we've always emphasized, the visibility into how the model is working.
So from what I'm hearing, the two of you, PhD holders, have put a fair amount of work into developing the ability for people to have access to and make use of models and reuse those models. Does everyone need a PhD on staff to have the ability to make use of these things?
I think we'd be failing at our job if that was the case, right?
That's right.
The goal is to try to make this, make the technology usable by people who are domain experts, in this case, in the law or in investigation, or whatever, and give them the insights into, through visual analytics and statistical measures and whatever, and training is important as well. Into how to think at the level of process. How is the behavior of this AI system going to interact with the human processes, because the human processes are always extensive around these projects, but not to have to understand the math, not to have to sort of go to school. I mean, I can't count the number of attorneys who've told me, I went to law school because I didn't like math, right? And so we sort of, and Irina's team as well sort of emphasized sort of giving people, I guess you'd say, qualitative insights into how these systems work without them having to kind of dig into the software or the math.
That's right. That's right. So we believe our platform provides the features, the tools, solutions, the library of the models, exactly so that our users can just use them and use their own workflows and expertise and really not be experts in data science or AI.
Yeah, there has been and there continues to be a lot of discussion back to something that one of you mentioned about the plumbing of all of this. SVM versus this versus that and so on. And a lot has been written on that front. It has always seemed to me, both my brothers have PhDs. They look at me with a JD and say, well, you're the dummy in the family. It has seemed to me that as I look at this with a lawyer's perspective, what I really care about most is getting results that help me move my case along. And yes, I need to have an understanding about how I got at those results, but I'm not sure I can always figure out what was going on in my own head either, if I were just thinking about things. How does that play out? The results achieved and ways of making sure that they are supportable results, not unduly biased by something, for example, versus looking at the mechanics of how it operates. Who wants to take a stab at that, Dave?
I mean, that's a big, obviously that's a big question to unpack. Yes. And I think you're right in emphasizing there's several components to that. There's obviously the design of the overall workflow, which often includes human checks and balances and reviews on things and whatnot. And I think that's an area where, attorneys have been doing that for decades, really. So how do you manage teams of reviewers? How much coffee do you give them at 4 p.m, right? That sort of thing. And then, now there's this new level, which is that the machine informed by human knowledge is making certain discriminations between documents. And if you design a workflow that way, maybe that means, no human being ever looks on certain documents. And so you have to understand that. And people do things like statistical sampling and various kinds of searching and using other analytics to try to understand maybe what's not being looked at in those circumstances. I'll say, just to bring up a kind of very topical issue, we're increasingly seeing, particularly from financial services organizations, them doing model audits. So that is, they, because of their regulatory needs, have certain requirements for understanding in a pretty formal way how AI models work and documenting that and how it affects their business. And and I think this is an area of it's where the boundaries are under negotiation right now, but some of them feel that e-discovery models come under that as well. And so we've had several audits of our technology where we've had sort of long questionnaires and long interviews from model audit teams and whatnot. And I think this is all very much to the good that people are developing formal processes. And, the law is about sort of, routinizing certain processes for understanding and making sure that, the people with the appropriate responsibility understand how the technology is affecting the legal process.
Irina, your thoughts?
Yeah, sure. To add to that is, so I believe it is great that our clients are curious and that they're aware that there are support vector machines and deep learning, and especially deep learning is just such an exciting area. So I think that is kind of really very beneficial for everyone. And it is good they're keeping us honest. These are very good questions, right? And Dave and I, we're working, and our teams are working on being up to speed, knowing all the latest like academic results from our peers, so that we can answer those questions in the best possible way, right? But and also agree that kind of the evaluation aspect of it is extremely important. The technology assisted review has been used in e-discovery for a long time. There are very good processes around defensibility of those results. And I think it's great to kind of take that experience even further and apply it maybe to more and more AI technologies, right? Because George, as you're saying, by the end of the day, it needs to produce the results which are helpful, efficient, correct, and so on and so forth, whatever is required by the given workflow. but understanding like really very deeply under the hood how the exact algorithm works. If somebody's curious, would like to take some Coursera courses and educate themselves, that is wonderful. But I don't think it should be required for anyone practically to be use to use the technology. I always think about like my phone, right? There is so much AI which goes in so many applications, but I just like see it detects faces on my pictures, or I can search my pictures. I'm a user of that technology. I'm curious how it is done. I would like to see some blog posts from them kind of with the highlights of the technology. But by the end of the day, I'd like it to work correctly, right? So that's really my objective here. And I don't want to oversimplify the workflows that our users are facing. But I think it's a little bit a similar approach, right? So I would like the conversation to be around, is it really the best? Like, can we, like, say at Reveal, can we show we are using the best possible technology? And then how do we evaluate that it is producing the results we expect?
Jay Lieb, our colleague, is fond of saying some variation of we've got the strongest or the best or whatever it is, AI team in the industry. And our AI team starts with the two of you, but it doesn't end with the two of you. Tell us a little bit more about the team of people we have working on all of these issues.
Irina?
Sure. So we have like four full-time team members, data science team members. One will be joining very shortly. So it'll be 5 very soon. And everyone has been on our team for many years, except obviously for the new person, but many years. And they really have been growing together with our team, with our application. We've been, figuring things out, had a lot of productive discussions, some things which did not work out in the end, but we had like a lot of interesting projects. And I think it created a very productive and creative dynamic within the team. So now, we are excited. We're always learning about new technologies. We have, individual team members might be more interested in one or another area of machine learning or AI. So they will bring their own ideas to the table. So yes, we have definitely, it's definitely not me. I'll say not just me, for sure. We have a whole team working on all the, wonderful things that we've accomplished so far.
Yeah, and then one of my hats is I run the AI engineering team. I've got a couple of long-time developers who've been in the industry for over 10 years, and I think one thing I would mention there is because this gets talked a lot in the development community. I mean, both the guys on my team, they didn't do their degrees in artificial intelligence. I mean, there are people who, they did masters in computer science. They are longtime developers who over the years, learned a lot about AI. I mean, they're experts in their areas now. I do think that this is something that gets talked a lot in the dev community. I mean, can you move into AI, or you have to, and I really do think that, it is like many other, complicated technologies in computer science, and that good developers can take on, whether that's AI or cloud computing or parallel processing or whatnot. So I always, I always encourage people, Irina mentioned Coursera. There's been, the resources that are online for self-education now are just astonishing. And so I've always encouraged people to go learn, and statistics too, because I'm a statistic.
Right. And also the same goes for young and aspiring data scientists, right? With the big degree and background. So for our part of the team, everyone joined as an intern first, and they just, did a very good job, like the team, everything worked out, and they've been with us for years now. So that's another thing to say, that don't let anything stop you. If you're excited, if you're passionate, please pursue this career, definitely.
So we've got just a few minutes left. I'd like both of you to sit down with your murky crystal balls, peer into the future. There you go. And give us your thoughts about where possibly we may be going with all of this. not disclosing, of course, anything you shouldn't disclose, but thoughts about what the future of all of this might look like for us.
I guess the question is how far out a future are we talking about here?
I'm leaving that. So this is the analog to the question I ask of so many guests, which is, if you could have your ideal e-discovery platform, what would it look like? Assume no limitations of any sort whatsoever. This is why you get to use a murky crystal ball.
Okay, yeah. Well, then
no one will hold you to anything.
I should look at these old videos to see what we should be working on then. I think we're going to see, increased sophistication in small increments of the degree of understanding that language technology has of documents. And so, we launched with AI and e-discovery, and what I always try to stress is that people have this attitude of the law as kind of like pokey or conservative, the law was really early to adopt AI. In e-discovery in particular, they've been way ahead of other industries, and so I think the early applications were kind of search and yes/no classification and things like that. And I think increasingly, and Irina's team works a lot on this, is bringing deeper insights, relationships between documents, and operating not just at the document level, but at the important domain entities, people, transactions, organizations, and relationships between those, and understanding those over time. So I think, we're not going to have the Star Trek kind of computer that says, give me the perfect legal strategy for this case, and it comes back with a diagram and 3 documents or something. But what we'll have is increased understanding of the meaningful entities in a legal case or investigation or whatever, and increasingly good analytics for displaying those to users. And so, I'm a great believer that while AI has these kind of hype waves, the actual progress I think has largely been slow and steady for the past 60 years. And I think that's what we'll continue to see. And then just increased ability to kind of communicate that to users, which I think has been a larger emphasis the past few years.
Thanks, Dave. Irina, let's close with your thoughts.
Thank you. So I think it will be really moving towards understanding language, right? We do have natural language processing technologies, but now with deep learning, we just have new set of capabilities there. Mm-hmm. We introduced the BERT technology. We're now using multilingual BERT when you build your model in one language and it works on 104 languages out of the box without doing anything extra. These are great things. This future is now, so to speak. It almost like, very tangible. And I believe it will be more and more interactive. So I would like to see and let our users interact with the system and really ask questions, natural language questions, and maybe insert some information about the case, and the system will adapt, adjust, recommend. Because it will have stronger and stronger technologies for understanding the communications content, as Dave was saying, personalities, and so on and so forth. And I really imagine, maybe a little bit further into the future, but I really imagine it being much more interactive in that sense, and really providing information, kind of surfacing it almost dynamically as the user goes and interacts with the system.
Well, thank you. Thanks, Irina. Thanks, Dave. Irina is Reveal's Chief Data Scientist and Head of Machine Learning. Dave is Reveal's Executive Vice President, AI Research, Development, and Ethics. I am George Socha. This has been eDiscovery Leaders Live, hosted by ACEDS and sponsored by Reveal. Thank you for joining us today. Please join us next Friday, April 9th, when our guest will be Tony Milliken of Trinity Industries. Thanks.
Thank you.